So in this chapter, we're going to talk about molecular formula. So molecular formula is gotten from empirical formula, and it helps us to identify the actual number and type of atoms in a molecule. Now let us do a question. You're told a hydrocarbon was found to contain 92.3% of carbon, and the remaining part is hydrogen. So let us just do the remaining part before we proceed. So hydrocarbon is a compound that is made up of two elements only, hydrogen and carbon. So one part we have been given for carbon is 92.3. So let us look for hydrogen. So the percentage of hydrogen in the hydrocarbon will be 100. You minus 92.3, you get 77%. Okay. Now let us continue. You're told if its molecular mass is 78, determine the molecular formula. So we said you get the molecular formula after working out the empirical formula, in cases where you haven't been given the empirical formula in your question like this. So you write element here, you write carbon, and then you write the other element, which is what? Hydrogen. You write the percentage composition by mass, okay, which is going to be, percentage composition is going to be 92.3, and for hydrogen is going to be 7.7. And then we write the relative atomic mass. So the relative atomic mass of carbon is 12 and of hydrogen is 1. So remember, the relative atomic mass is gotten from the mass of carbon and hydrogen, and you're normally given in the question. This is the mass that you get indicated on the periodic table. Okay, so the relative atomic mass is 12 and 1 respectively. So we said the empirical formula gives us the simplest mole ratio of atoms. So we are going to look for the mole ratio. So before we get the mole ratio, first we need to look for the number of moles. Okay, so the number of moles, how do you get mole? We say mole is given from, we say it is mass over molar mass. So it's going to be 92.3 divided by 12, 7.7, you divide by 1, and the mole is going to be 7.7 for that, and 7.7 for this one. So let us look at the mole ratio. Moles can also be denoted as N, that's why I've written N here. So mole ratio is going to be, you take the moles, you divide by the lowest mole or the simplest, which is 7.7 for both, and then you get 1, 1. So the mole ratio is 1:1. So the empirical formula of our hydrocarbon is carbon has 1 atom and hydrogen has also 1 atom, so it's going to be CH. Now let us work the molecular formula, because we have already gotten our empirical formula. Now we are going to say the molecular formula is equal to the mass of the empirical formula. So we got the empirical formula, which was CH, right? So it's going to be CHN is equal to our molecular mass. We were given the molecular mass and we were told it was 78. So it's going to be the mass of the empirical formula is equal to the molecular mass, which was given in the question, and it was 78. After you do that, you come and calculate the mass. Higher the mass of carbon, you get it from looking at the mass that is given in the periodic table. So carbon, the mass of carbon is 12. The mass of hydrogen is what? It's 1. So the mass of our empirical formula is going to be 12 plus what? Plus 1. So it's going to be 12 plus 1, n is equals to 78. This is 13, n is equals to 78. You divide by 13 to get what? Our number, which is, or our n, which is going to be what? 6. So the molecular formula is going to be CH 6, which is C times 6, which is C6 H 6. So that is the molecular formula of our hydrocarbon. And that is how you calculate the molecular formula.